And hello, my wonderful AP students. This is your day 4 video. We're going to do some hardcore studying about graphs. We're going to first quickly just talk about acceleration a tiny bit, just to give you a little heads up on some things that I think you may not have completely got from class. Then we're going to go completely in depth about graphs, now they relate to displacement, velocity, and acceleration. This is some big time stuff coming up your way. So as always, I'm going to need your notebooks out. You're going to be doing some notes for me, and you'll also be drawing a bunch of pictures. So as always, you're going to have to pause, rewind, or do whatever to make sure you understand fully from this. So first of all, acceleration is real quick. You can even add this to your notes you took in class on day 3. Let's see how the signs of velocity and acceleration compare for two situations. If you're speeding up, either forward or backward, doesn't matter, velocity and acceleration are going to be the same sign. If you're slowing down, either forward or backwards, velocity and acceleration are different signs. This will give you a nice little idea of what's happening. So with that being said, it's now about graphs. I'm about to give you kind of 5 big strategies to use to understand graphs. Graphs are intimidating in physics because sometimes they curve, they have to know your concavity, whether they curve up or curve down, whether they go to infinity or stop at a finite number, and there's a lot of things you're going to be doing with them because they're very good at giving information, unlike tables. So strategy number 1, let's start. There are only 3 things you can do with a graph, just 3. The first thing you can do is just read a value directly from the y-axis. Look at the y-axis, look over to where the line hits, there's your value. The second thing you could do with the graph is take the slope. You can take the slope for the entire graph. Just look at the start and end point, and that's it. And then draw a line between them. That's your overall slope. Or, more importantly, you could take the slope for one segment or many segments along the line. This is especially true when you have curving graphs. And the third thing you could do is find the area under a line or under the curve that you're given. Again, for the entire graph or for the segment. And the slope and the areas, as we saw in the previous homework, allow you to go between different ideas like displacement, velocity, and acceleration. So strategy 2. This is going to screw you up a bunch of times. I'm just going to say it even though it's kind of common sense. Always identify the type of graph it is from the y-axis. There are 3 kinds, pretty much. Position graphs, where there's some kind of length. Velocity graphs, where there's some kind of length over time. And finally, and rarely, acceleration graphs, length over time squared. Quick note, in this class and pretty much up through, I think, the first sequence in college, you will always assume accelerations are constant, which means your acceleration graphs will always be a horizontal line, either at 0 or at some value. Strategy 3, you're almost halfway there. Now a little bit more inventive stuff. Here's the deal with graphs. Calculations are important. You're going to do a bunch. But even more important on the AP exam and just knowing physics is having to describe and predict motion in words and justify it from the graphs. So the strategy, never just do the math. Never. Always quickly figure out how the object is moving from the graph before you do the math. An example would be, is this speeding up as it's slowing down? Is this going to go to a value? Blah, blah, blah. I'm going to show you what I mean through the next couple class periods. Strategy 4. This one is the one where it starts getting to be really good. Graphs allow you to determine displacement, velocity, and acceleration from each other. So the direct reading, it gives you the unit on the y-axis. The slope gives you the unit of the y-axis divided by time. And the area gives you the y unit multiplied by time. So let's make a table of all the possibilities. And here we are. The 3 types of graph: position, velocity, and acceleration. And the 3 things you could do: direct reading, slope, and area. So direct reading is that type of graph. Position graph, you read it directly, you see position. Velocity graph, you read it directly, you see velocity. Acceleration graph, you read it directly, it says acceleration. Slope. Position graph, position is meters, slope you divide by time, you get meters over seconds, so the slope of position graph gives you velocity. And the slope of velocity is meters per second squared, so the slope of velocity is acceleration. The slope of acceleration is a jerk. which is not really used in physics. Again, because we're talking about constant acceleration, the slope of acceleration will always be 0. And finally, area. Area is the type of graph times time. Position, area is meters seconds, which is nothing in physics, which is kind of weird. I had to look it up because I thought it may be something just kind of unique. Not really. The area for velocity is meters over seconds times seconds. So you just get meters. The area for velocity is displacement. And for acceleration, the area represents the velocity. My calc A, B, and BC people, you can think of slope as the word derivative. Area is antiderivative. So this is a pretty important table for you. And strategy 5 involves velocity graphs especially. So for velocity graphs, there are 3 things to keep in mind. Number 1, and you'll see little pictures to make sure this makes sense. A direct reading above the 0x line is positive velocity, below it's negative velocity. The area below the x equals 0 line is negative displacement. And here's the big one. You cannot determine the starting or end position, only the change, from looking at the area. So if you find that the area underneath the curve for velocity is, let's say, 10, you know that the displacement's 10 meters. But you don't know if it was from 0 to 10, or from 1 to 11, or from 100 to 110. You have no idea about where it started or ended. You just know the change. My calc people, this is called the plus C argument in integration. Because you know how much it changed by, but you don't know the starting or ending conditions. That's why you always add plus C. Here's a cute little picture I found online of velocity time. Look at that red line. So, if you read it directly, any of the values from this point down to this point is a positive velocity. Any point from here down to this negative is a negative velocity. Of course, because it's below 0. This orange area is the displacement at this time, and it's positive. Now, you could have also find the displacement from 0 to, let's say, this time. It'd be this chunk of distance. So again, this is the displacement from 0 to this time period. If you look at it a little bit beforehand, you're only filling in part of the triangle here. This pink area down here, this triangle, is negative displacement. It's below the axes. So this is the displacement from this point to this point in time. And again, if you're looking at this sometime in between, you're only going to make a segment that corresponds to that area underneath the curve. Now overall, how do these two areas compare? Well, they look pretty much equal. So if that's true, this positive d and this negative d combine to be 0. So in the overall time here, the overall displacement is 0. And that's the starting point to looking at graphs. When you come into class, we're going to do a lot more in depth, a lot more discussion. We're going to see how calculus relates to us. And we're going to set up our first real lab, which is to be you making graphs like this using motion detectors and figuring out what is occurring. Thank you and have an excellent day.